Hey, what's going on, guys? Welcome back to the channel. So in this video, I'm going to be discussing something that's really important to know while you use ScrollSmoother of GSAP in React or in Next.js. So a few weeks back, I made this component wherein we have a bunch of images, and when you scroll, we have this parallax effect. The images have different speeds, and then also they kind of get skewed when you basically move fast. So yeah, this is pretty cool and fun effect that you can use in your images in your website. Now, the source code of this is this, which I'll also link in the description if you want to know. And then also I'll add the link to the video. If you haven't seen the video out how to build this, I'll just add that in the description. But I think it should be fine. So here we have this, which is in vanilla JavaScript. So usually when I build anything or a fun component in using GSAP, I usually like to build it using vanilla JavaScript because it's easier as well comparatively building it in React. So I tried having the same effect using the same sort of logic in React, but what I ended up having is this. So I have the image which is not working as intended. These images are basically interfering with other elements. They're sort of hijacking the entire screen. I can't really click anywhere, so it's pretty messed up. So what I want is I want these to be inside of the div behind, and then take respective height, and not just hijack the entire screen. So if I show you the code is pretty simple as of now. So we have this scrolling gallery demo, which has an array with a source, alt, and then the speed. Now, if you look at the original vanilla JavaScript code, we also need this data speed, which is something that is predefined in a smooth scroller. Scroll smoother, which basically lets you have different speeds for the different images. So we have this speed defined for each of the individual images. And then here we have the scrolling gallery component. Now, the scrolling gallery component takes in the images which we're passing, class name if you want to add some extra styling, and then we have ID. In this case, we have the default ID as wrapper. Now, why do you have this ID? So if you want to have this scrolling gallery component used multiple times, it's recommended to add dynamic IDs to each of the individual scrolling gallery, else it would interfere with each other, which is not what we want. So since I already have it used once, so I didn't add any ID, but yeah, so there's that. And then we have this use GSAP hook, which is from GSAP, which is a basically like a better alternative to use effect or use layout hook if you're using GSAP. Inside of that, I have the same logic that I had for the JavaScript, the vanilla JavaScript. So here I just have the same logic here when we have the skew setter with gsap.quick2 when we have the dynamic ID used. And then we have the clamp, we have the scroll smoother, which creates the smooth scrolling with smooth speed effects. That's true. And then on update, we basically trigger this skew setter. And then for the wrapper, we have the ID. And then for the content, we have the ID content, which are these. Now, what is actually happening wrong is if I inspect and if I show you, you'd see that this, we have a div which is taking up the entire screen, which is this wrapper div. Now, if you notice, we have the wrapper as inside 0, meaning take from 0 top, 0 left, 0 right, and 0 bot, with position fixed, meaning it is now in respect to the viewport. So this is what we want. What we want is we want this to be based off its parent. So what we have to do is here, we need to add the style with JSX. And then here we target the ID. And then we add position as relative. We don't want fixed. Make sure to add this exclamation important just so that this has a higher priority and this overrides the existing scroll smoothing CSS, and then we want inset as auto, overflow is hidden. Let's save. And now if I refresh, you can see that we have the effect, but we have a lot of empty space here. Now, why do we have this space? The reason for that is because if you look at the images basically move up and they translate out of the viewport. Now, when this container basically moves out, the parent has the exact same height that was given based off the content. Now, since the elements are gone, we have this huge empty space. So what we have to do is, instead of having a fixed height or no height at all, we need to generate height dynamically. Now, if I show you the content here, it has this translate transform property with matrix 3D. Now, you don't really need to understand it completely. So the only thing that you can take note of is when I scroll, you see this 14th value, or if we count with index 0, this would be the 13th value. You'd see that this basically changes. So the value basically changes when I scroll. And this is basically what is responsible for having the container go out of the screen. So we can't really prevent this. If we prevent this, the effect won't be as we want, but instead we need to dynamically generate the height. So here we can add height as dynamic height pixels. This would again be important, transition, and a default main height of 100 viewport height. Now if I save, it's going to throw an error because we haven't really defined the dynamic height. Now the dynamic height and set dynamic height would be a number type. We set them as default as 0. And then we grab onto the content element and then the wrapper element based off the ID using getElementById. Then we make our function that's going to be responsible for calculating the height visible. So we have calculate visible height function. Now this function is going to get triggered every time this thing updates. So we have set dynamic height, and here we set it as the calculate height, since this function would return the height. And then again, when we scroll, even then we want the height to change. So we have this here. And then also when we resize the page, we want the height to be again dynamically calculated. So we have this handle resize. We add the event listener of resize and handle resize. And then we add a cleanup function just so that the event listener don't start stacking. So we remove that. And when I save, we don't see much changes because it still isn't basically calculating the height dynamically. So inside of this calculate visible height function, we first get the height of the wrapper element. Then we'll look for the transform property that is inside of the content element, which is basically this thing. So we need this. So for that, we have transform content element.style.transform. We get the transform. We use a regex matching, which is regular expression matching. We get the 3D match. And then if this exists, then we do something else, we return as 0. So if this exists, then we have 3D matrix value. So basically here, if we look at this, we have two matrix values. Now I can't really console and show you, but let me just print it out here. So if I just console here and type matrix 3D, save, console, refresh. As you can see, we have this array of two elements, 0 and 1. So we basically look for the second one. You can also use the you can also use the 0th index element, it's fine. And then we get the values by splitting using comma. And then we want the 13th index value, which is let me scroll. It's this one. If you count from here to here, it's going to be the 13th element. So we have that. we have the y translate. And then what we want to do is we have this base calculate height. This would be responsible for calculating the height dynamically. So we have the wrapper element's height. So if we have the wrapper element's height, what we do is we add it with the translate y. Basically, the value that the element got translated to, we just add it. Now, if our wrapper is empty, we want to throw the height as 0. Now you may think, why are we adding y translate instead of subtracting it? The reason for that is the value is already negative. Since if we add here as negative, it would end up basically having a positive value. So what we want to do is we'd just have this add up, which would in turn be subtracting itself, and then we just return the final height. Now let's save, and if I refresh, when I scroll, you can see it works well. It's pretty nice, right? Now, there is one issue that you might end up triggering. And the issue is, let's just say you have this, and then for some reason you have the last element or so, the speed more than 1. Let's just say 1.5. And when you save, let's refresh. And when I start scrolling, you might see that the last image is overflowing and it's not visible completely. So what happens is when you have the speed less than 1, it usually has the transform translate y as negative. And when it's above 1, it's usually positive. So what I mean by that is, let me inspect and show you. So each individual image here has its own translated value, like this. This has a translate y of 103. The reason for that is because it is above 1. Now, this value, which is less than 1, I can show you just above this, it has a negative translate value. So when you have a negative value, the element would basically move up. Now, as long as the element moves up, you don't need to worry. But when the element starts moving down, that is when the element becomes or is not visible when you scroll. So we just have to look for the positive translated y value of the element. Now, which image would usually be not visible? The image that is at the last is generally which is not visible. So what we have to do is here, we grab onto the last image. So for that, we first generate the ID for that. We have this ID as the dynamic generated ID. We target the image and then add last child just so that it grabs the last child. We have the last image. We have the initial last image translate value is 0. And then if we have the last image, then what we do is we grab the transform same way as we grab this. We have the transform property. We can console it, or we can use again the regex matching, this time for the translate. And if the translate has anything, then we grab the image y translate from that. We basically translate, match that. We grab the index of 2. Now you may think, why do we have the index 2? Let me just console and show you what exactly this translate match has. Translate match, save, go to the console, let's refresh. Okay, so here, as you can see, we have 3 values. This is the first one. This is the second one. This is the third one. So we need the third one. So if you need the third one, obviously the value would be 2. So there's that. And then what we do is we had the last image translate as 0. So we just add onto it our image y translate. Let's save. Now, even if we save, we won't see any changes because we're not actually using it anywhere. So what we need to do is we need to add this to our final height, which is this base calculated height. We need to add onto it. Now, when do we add? We don't add this every time. So we first check if the last element has a value above 0, meaning that it is not negative and the element is not moving up. If the element is moving up, or if this has a negative translate, we don't really need to worry. But if this has a positive translate, meaning it's going down, only then we add the translated amount. And let's save and close it. Let's refresh. Now when you scroll down, you can see that we have the image properly visible. Now let's change this value to, again, a value less than 0. Let's just say 0.5. Let's save. And now if I refresh, I scroll down, you'd see that it's visible. This element moves up, so we don't really need to worry. This is it for this video. Meet you guys in the next video. The source code, I'm not going to be sharing the source code yet because in a few weeks, I'll be sharing with you guys what I'm actually working on. So you guys have to bear with me. You just have to wait. So yeah, this is it for this video. Meet you guys in the next. Till then, bye bye. Take care and peace.